physics help you sleep at night? We did an experiment, the design, that tested the force behind the Breathe Right nasal strips. As you can see in our picture here, we have a string tied between our nasal strip and a force detector, and we pull on this force detector with the nasal strip and to a certain desired angle, and it tells us our force. This here is us pulling the nasal strip to 90 degrees, and we measure our force on Logger Pro. This is our second trial where we had to flex the nasal strip 10 times before we measured. That's what it looked like when it's flexed. We did that 10 times. This is how we measured the angles that we took the nasal strip to, 45 and 90, with a protractor. This is what the nasal strip looked pre-10 flexes. This is what it looked like after 10 flexes. This is the extra strength nasal strip that we measured the same way. And here's some of our experimental results at 90 degrees and 45, showing our forces at each degree. And for question number 1, is the vent strip perform as an ideal spring with a single spring constant throughout the effective range, or does it have several performance zones with different spring constants? With our experiment, it does have a single spring constant throughout 0 to 90 degrees, so it has one effective range.
Our second question was, does the direction of motion, squeezing or releasing, affect the available force? Our answer was no. We know this to be true because of Newton's third law. For every action, there is an equal and opposite reaction.
And in order to understand number 3, which is the force curve reproducible, you must understand the formula of force for a spring constant. You can see here that force is equal to a constant times your distance. And when we calculated, first of all, for just a regular Breathe Right strip, we found our K's, our constants, to be fairly similar. So in explaining how we found our distance, we were looking at the circumference of a circle based on your Breathe Right strip as your diameter and your angle as the length that you go around the circle. So if our Breathe Right strip had a circumference of 2.25 d, we would take a fourth of that in order to calculate the distance it went at 90 degrees. So as you see again that your K's are relatively constant for trial 1, and your K's are also constant for after our 10 pinches. And you also see here that your K's are constant when looking at the extra strength. This would then suggest that our trials are indeed reproducible.
In order to address our fourth question, is there a measurable deterioration in performance after 10 flexes? Our data from Logger Pro would suggest that there absolutely is. With our first trial, we measured the force that it took to get to 90 degrees of one of the regular strength strips, and as you can see, it's between 1 and 1.3 newtons to get it to 90 degrees. When we did our 10 flexes, we saw a decrease in the amount of force that it needed to get down to the 90 degrees. And with our extra level advanced nasal strips, there was an increase in the amount of force to get it down to the 90 degree angle as compared to our previous one of 1.2 to 1.6.
And our fifth and final question is the Breathe Right extra performance claim of 50% stronger a valid claim? It is not valid because it's not 50% stronger. From our graphs, you can tell that it is stronger because it goes from a force of 1.2 for the regular strips to a force of 1.6 for the 50% stronger strips to get both to 90 degrees. So it's stronger but not 50% stronger. The physics behind says that there is a force applied to your nose that should help you breathe better. You have to sleep with one and determine if it works yourself.